Hello class, welcome back. Today we're going to go ahead and continue section 7.4, right? And we're going to go ahead and use, these methods that we use in 7.2, right, to go ahead and put everything in the bigger picture, right? And if you notice, right, it's the same pattern, all right? So specifically for this section, right, confidence intervals and sample size for proportions, right, you're going to be giving these proportions in percentages, all right? You're going to be giving these proportions in percentages, all right? And that value, right, let's just jump straight, right, let's jump right straight into it, right? This value here, right, which I'm going to denote as p hat, all right, is going to be my sample proportion. Right, and this sample proportion is going to go ahead and be that percentage value, right, that you're given. It's very different than the confidence interval, right? We know with the confidence interval, we do these steps here, right? These 5 steps, right, to find my z alpha over 2. So the key thing here is to differentiate those, right? Right, they're going to go ahead and give you that proportion, right? And this is 32%. Right, but we know we don't want to use it in percentage, so I know this is 0.32. All right. There we go. Very nice. All right. And we know, all right, again, right, whenever we're dealing with this population, right, whenever we're dealing with this population, just like our test 2, right, I got my q hat here, and what do we think q hat is going to be? What do we think q hat is going to be? All right, that is going to be 1 minus p hat, all right, which is going to be 1 minus 0.32, right, which gives me what? So right, this gives me 0.68, all right? And as a reminder, right, adding your p and your q should give you 1, all right? Okay, very nice. All right, so these are values I've been able to differentiate from what was given, and as well as my sample size. All right, I see here that my sample size is 1100. All right, and let's get right into it. All right, so we're going to go ahead and find the formula for. We're going to use the formula for a specific confidence interval for a proportion. All right, where your formula, right, is going to be p hat minus e. All right, bounded between p hat plus e, all right? And e is going to be my margin of error, right? E is going to be my margin of error. Right, so you may be saying, okay, if you're looking for, right, the formula, right, if you're going to go ahead and look for the formula, again, I'm sorry, this is going to be in page 383, all right? 383, right? And, right, my margin of error, right, let's go ahead and put it below this one here, all right, would be my z alpha over 2 value times the square root, right, of p hat times q hat over n, all right, q hat over n. Right, so you may be saying, hey, the formula you wrote here, right, it looks a little bit different, right, than the one that's given in the book, right? It's the right when you include your margin of error, right, it ends up giving me that formula, right? It ends up giving me that exact formula, right? So let's go ahead and move this up here. Right, so perhaps the next thing we may want to find, right, it's that margin of error, right? Let's go ahead and find that margin of error. So, right, we said my margin of error, right, was that. So, right, let's go ahead and find my z alpha over 2. All right, let's go ahead and find that first. All right, let's go ahead and find that. Let's go ahead and see the confidence interval that was given. It is 99%, all right? So I know, right, for my step 1, right, it's 99% divided by 100. This is going to give me 0.99, all right? That's set for step 2, right, to find my alpha. It's going to be 1 minus that value. It should give me 0.01, right? We have said step 3, all right, was to find what? off over 2, right? So this is 0.01 over 2. So it's going to be what? 0.005, right? Over 2. Right. My fourth step. Right. My fourth step is to find 1 minus alpha over 2, which is 1. Wait, what did I put? There we go. It should be 0.005. All right, there's a 1 minus 0.005, right? And what does that give me? That this ends up giving me 0.995. And last but not least, right, I can go ahead and find that z value. Again, right, you want to go ahead and have this sheet printed out, right, beforehand. All right, so I'm looking for what I'm looking for again, 0.9950, right, 0.9950, right, it's up to 4 decimals, 0.9950, 0.99, again, right, we said if you had to, where is it, what was it like, oh, up here, right, up here. All right, do you remember what we had said? What do we do if I'm bounded exactly the same distance, right? Between both of them, you round up, all right? So that means we're going to go ahead and look at this one. So this is going to be 2.58, right? That is my z value. So z, let's go ahead and get rid of that. All right, so 2.58. Whew. All right, so I got that out of the way. All right, at this point I can go ahead and find my margin of error. All right, this is z alpha over 2. All right, this is the formula here, which is going to be 2.58 times the square root of p. All right, this here should be multiplication. So p, which is up there, I got 0.32 times 0.68 all over, what was my sample size? 1100. So let me go ahead and do what's inside the square root first. All right. Let's go ahead and do all of that. Square root of 0.32 times 0.68 divided by, let's see, 0.32 times 0.68 divided by 1100. What does that give me? I get 0.00140647885. I'm going to go ahead and multiply that answer in my calculator times 2.58. Right, and this here ends up giving me intermediate answer to 5 decimal places, right? So all these intermediate answers, right? So we're going to go ahead and round this middle part up here. You would want it up to 5 decimal places up to there, right? So here I would go ahead and do my margin of error 0.03629. All right. Should be a 0. All right. So I don't have everything that I need for my formula, right? It is p hat minus margin of error bounded by p hat plus margin of error, right? Which gives me 0.32 minus 0.03629 bounded by between p, right? Less than, all right? Where you by p 0.32 plus 0.03629, all right? Very, very, very nice. Where p is my, right? My population proportion, right? Again, right, it's going to be very, very helpful to go ahead and catch up on, not catch up, definitely not catch up on, right? Read ahead, right? Skim the book ahead of schedule, right? So I get 0.32 minus 0.03629, right? And it wanted, right? So let's go ahead and run 0.28371 bounded by population proportion. 0.35629, right? And of course it wants it, right? It wants the final answer to 3 decimal places, right? So this here would be 0.284 prop 0.356, right? So that's exactly what you're looking for. Right? This is exactly what we're looking for. All right. I wanted to go ahead and mention something else. All right. If you look at page 385 in your book, all right, the sample size for proportions is right. You may have to find out yourself. All right. And as long as you know the margin of error formula, you're going to be able to go ahead and find the minimum sample size, right? And very similar to, I believe it was 7.2 as well, right? If it was not 7.2, it's definitely 7.3 where we use that formula, right? So, right, so I have, right, let's go ahead and take off from my margin of error, since that's the one we're familiar with, right? It's the one we just looked at, right? And I want to go ahead and solve. I will need to go ahead and solve for n, all right? N is going to be my focus, all right? So that z variable, all right? I don't want that there, all right? I don't want that there. So in case we're confused, right? In case we're confused, what are we doing right now, all right? Let's just say that I am dealing with a is equal to b square root of yz over x. All right, that's what I'm dealing with right now. And I'm trying to solve for x, all right? So meaning, in order for me to get inside the square root, all right, I need to take care of the square root. But in order for me to take care of the square root, I need to get rid of anything that's behind it and in front of it, all right? And I see here that this b is right in front of it. And how do I get rid of b? Right? Well, b is multiplying with what's my focus, so I'm going to divide both sides by b. Right? Leaving me with a over b is equal to the square root of yz over x. Right? So how do I get rid of the square root? Yeah, you square both sides, right? So I'm left with a squared, a over b squared, right, is equal to yz over x, all right? Yz over x. All right, what shall I do next? All right, so, all right, one thing we may want to do is a over b squared, that's one term, and it's being divided by just one, all right? So I want to go ahead and cross multiply, all right? So this is yz times 1, and this entire parentheses times x. So this gives me x, right, times a over b squared, right, is equal to yz. All right. I want to go ahead and get rid of that ab squared, right? So this is going to be a over b squared divided by a over b squared, all right? Which gives me x is equal to yz over a over b squared, right? And if you remember from college algebra, right, if you have 1 over x squared, right, you can bring that squared to the top by switching it to a negative, right? So this is the same thing as x to the negative 2, all right? Right, and similarly, right, if you have x raised to the negative 3, this is the same thing as 1 over x cubed, all right? So it's the same thing. In other words, I'm going to want to bring that ab squared to the top. All right, so this here, this is going to be x is equal to yz a over b raised to the negative 2. And last but not least, right, last but not least, if you have, let's just say a number, 3 over 2 raised to the negative exponent, all right, what you can do is flip the inside, and it's going to make that variable, that exponent, right, is going to make it positive. All right. So that's pretty much what I'm going to go ahead and do here. Then, meaning x, right, is equal to y times z times b over a squared. Whew. Am I going to ask you to prove this like this, or to go from one way to another? No. I'm just showing you where it came from, right? So now that our feet are wet, right, let's go ahead and solve for n here. All right. I would divide both sides by z alpha over 2. All right. So in other words, this is just e divided by z with the subscript, which gives me q hat over n. I'm going to square both sides. All right. So this gives me e over z subscript squared equals p hat times q hat over n. All right, again, we're going to go ahead and cross multiply. All right, so this here would give me n times e over z subscript 2 is equal to p hat times q hat. All right, another way you can see this is as, hey, I have 5 is equal to 2 over x. All right, you don't want no fraction, so you can multiply both sides by x. All right, leaving you with just 5x is equal to 2. All right, go ahead and see it that way as well. All right, meaning I will need to go ahead and get n by itself. So this is going to give me n is equal to p hat times q hat over e over z alpha subscript 2. Right, and I think by now you know what's going on here, right? Meaning my sample size would be p hat times q hat z alpha over 2 squared, right, and over e, right? And if you notice, if you look at page 385, that's exactly what's there. All right, so let's just say that you're in the exam and you only remember margin of error, but you need the sample size one. Don't forget that you can find it, right? So whether you memorize it or you want to solve it the long way, it's up to you, all right? All right, so let's go ahead and move on forward. All right, let's go ahead and move on forward. All right. Oh, and a not clarification, right? But whenever, right, for your book, right, whenever we're dealing with the sample proportion, right, your p hat, right, it's going to be your x over n value. Your q hat is going to be n minus x over little n. Again, right? You may also see it as 1 minus x over n, right? Or, right, you know what x over n is, right? That's just p, right? So this is the same thing as 1 minus p hat. All right. And it all depends, right? It all depends on what are we given, or what are we given. So awesome. All right. So the sample size will be your n, and just like before, right, our x values, the number of sample units, right, that we're focused on. Right. Go ahead and clear this up. Awesome. All right. There we go. All right. So students who major in business, right, it has been reported that 20.4% of incoming freshmen indicated they will major in business or related field, right? A random sample of 330 incoming college freshmen were asked their preference, and 66 replied that they considered a business as a major, right? So here, right, for those who are perhaps transferring to U of H, right, main campus, right, Bauer School of Business, right, right, you can see how it can be used, right, how it can be used, right? Estimate the true proportion of freshman business majors with 96% confidence. Does your interval contain 20.4%? All right. Ooh, all right. All right. So all right, I know here, right, I know here that I'm going to use this here to find my z over alpha over 2, all right, like our previous problem. All right, and you'd find out, all right, give me 1 second here. Not that value. I apologize. Where is it at? Oh, right here, right? My 96%, all right? And it says they're right confidence, right? It says that they're confidence, all right? So we know, right, that my first step is going to be turning this percent into a decimal, right, which gives me 0.96, right? You're going to go ahead and follow all these steps, right, just like before, right? And you should get, right, for your step 5, you should get z alpha over 2 is equal to 2.05. And moving forward, I'm not going to go over these in the lectures, right? You can go ahead and pause the video because we dedicated an entire section on finding that, right? But you are going to be required to learn how to find it for a few examples, right? In your in the incoming test, right? Unless that is given to you, all right? So if it's not given to you, of course we need to know how to find that, right? We need to go ahead and know how to find that. All right, so right, there's a lot of information here given, right? There's a lot of information here given. All right, so let's go ahead and break this down. I see here that it's random sample of 330, right? A random sample of 330, so that's already know that's my third sample, right? And 66 reply, right? That is my focus, right? We haven't seen that one in a while. That is my focus, all right? And right, for my formula, right, it's p hat minus margin of error bounded by p hat plus margin of error, right? So where, right, to remember what our margin of error is. Yes, and yes, please. Really, these are going to be provided for you, right? But you must know how to use them, all right? Right. So you may be saying, hey, my p wasn't given, right? The proportion. Well, what do I do, right? Well, what do I do, right? So, right, we said, right, if the sample size and the focus x is given to you, right? Where did I write that? Oh, it's up here. I did write it. Right? It's up there. All right, so p is going to be my focus over my sample size, which is going to be 66 over 330. And we'll go ahead and do the same thing before. We'll do 5. The intermediate steps are going to be 5 decimal points, and in the very end, we'll go ahead and round to 3, if possible. All right. All right, this gives me 0.2. It's very nice, 0.2, right? Meaning my Q, all right? It's up to you whichever one you want to use, but hey, right? Keep it simple, right? Keep it simple. Something we know, right? So this is 1 minus 0.2, which is 0.80, right? Hey, I have everything that I need, right? I have my Z value, my P value, my Q value, my N value, right? I'm good to go. All right, we said my Z subscript alpha over 2 was 2.05, right? Right. So let's go ahead and plug everything in, right? Let's go ahead and find my E, right? So my margin of error would be 2.05 square root of 0.2 times 0.8 over, where's my N? Let's see what that gives me. All right, we plug all that in. All right. It's a lot, right? 5 decimal, so 0.04514, right? That's what I got for my margin of error. Let's go ahead and plug everything in, right? Now, this here has been used. All right, there's the formula for that. Let's go ahead and plug it in. Let's go ahead and plug it in, right? So I got, where's my p-values? This is 0.2 minus 0.04514. Less than p, less than 0.2 plus 0.04514, right? Now let's go ahead and plug all this in, all right? Right here, right? I end up getting 0.1586. You right, and an identifier, right, to find out why do I have to use this p? Why can I not use that p? Because more information was given to you. All right, more information was given to us. Our sample size was given, right? My focus x was given, right? And if we notice, right, the initial part of that sentence is exactly what they need me to find, right? So this here would be my focus of my final answer, all right? Or part of my final answer, right? So, right, and I'm dealing with percentages, right? I want to go ahead and find out if my interval contains 24.4. Yeah, this should be a 20.4%, right? This should mark 20.4%. 20.4%. Not sure what. I could have missed it just like I did right now, right? Like that. Right, so that means I need to go ahead and multiply these both by 100, right? So this would here would be 15.49%, right? Bounded by, what's that, 24.51%. All right, and yeah, it does, right? The question was, does your interval contain 20.4%? Yeah, it does, right? It does contain, all right. It does contain it, all right? So very, very nice. So in other words, right, how does it all relate together? You can say that, you know, the mathematician, you're 96% confident that the true proportion of business majors are between 15.49% and bounded between 24.51%, right? Based on the sample size, or what, the 330 in college freshmen within the 66 that replied, all right? So very, very nice. Very, very nice. Okay. Let's go ahead and switch it up. Get this fixed. And for a third and last example, all right. Go ahead and get this fixed. All right, so our question is talking about obesity. Obesity is defined as a body mass index, right, BMI, of 30 kilograms over meters squared or more. A 99% confidence interval. All right. 99% confidence interval for the percentage of U.S. adults aged between 60 and 69 who were obese was found to be 30.3% to 31.5%. What was the sample size? All right. So here we go, right? Here's one where we would need to go ahead and find the sample size, right? So one thing to remember, again, right, we're dealing with the 99% confidence interval, how that covers, right? That covers my symmetrical from one endpoint to the other, right, due to symmetry of the confidence interval, right, given my sample proportion. The sample proportion is the average of the two endpoints of that interval, all right? So that means, all right, the interval I'm focused on is between 30.3% and 31.5%, right? And I need the average of these two, all right? I need it right smack in the middle, right? So here, this is point, right? That's 0.30.033. This here is 0.315, right? So to find my p hat, right, I need the average, right? 0.303 plus 0.315 over 2, right? And we'll go ahead and do 5. We'll go ahead and do 5 decimal places as well, right? Intermediate, right? Divided by 2. Oh, it gives me 3, right? So this here, right? We should get 0.309, right? And for my Q value, right? Sure, you can use the other ones, but you want to keep it simple, all right? This is 1 minus 0.9, right? Which we find out gives me 0.691, all right? Right, well, what else are we given? All right. I am given here my 99% confidence interval, right? or 99%. All right, I'll let you go ahead and solve this one by hand as well, right? So we know we're going to turn that 99% into 0.99, right? 1 minus 0.99 and so forth. Let's do the 5 steps. And you should get very nice, 2.58. And we know here, right, the margin of error, right? So the margin of error is going to be my difference between the sample proportion, right, and either endpoint of my interval, right? Either of that, all right? So let's go ahead and do the far right interval, right? So that's going to be 0.315 minus p, right? What was my p value? This is 0.309, right? We go ahead and plug that in. 0.315 minus 0.309. This gives me 0.006. All right, and you might be saying, hey, you said either. Why, all right? Well, if you wanted to use, go ahead and use the left point instead, all right? You wanted to go ahead and use the left point instead, you can, right? So this is option 1, this is option 2, right? And again, right, you're going to be using 0.303 and right, but your largest value is 0.309, right? And you just want the difference, right? You want the absolute difference. What does that mean, right? So let's just, right, in other words, the order doesn't matter, right, when you're dealing with absolute difference, right? So let's just say you did 0.303 minus 0.309 instead of 0.309 minus 0.303, right? You'd find out that this gives me negative 0.006. But what is the absolute value of a negative value? It's positive, right? So remember that, all right? Let's go ahead and remember that. The margin of error is the absolute difference, right, between the sample proportion, P, and either endpoint, all right? So at this point, right, I got my E, my Z value, my P, and my Q. Hey, I can go ahead and find everything that I need, right? Pretty much have everything that I need. So let's go ahead and find my N value is PQ, right? It's P, 0.309 times Q, 0.691 times, right, my Z value was 2.58 over margin of error 0.006 squared, all right? Let's go ahead and plug that in. Not square root, the 2.58 divided by 6 squared, all right? Squared. And I get here 39479.6631, right? And what did we say before? Do not forget, this is very, very important. You do not want to lose points for this, right? You always round up whenever we're dealing with n, right? Whenever you're dealing with your sample size, right? So, right, because you can have 0.6 of a person, right, in a study, right? So in other words, I'm rounding up to the nearest whole number, right? So this here is going to be 39480, right? So that is my sample size, 39,480, right? Next example. Oh, that's it, right? This is all we have, right? This is all I have for 7.4. But if you notice, it's very heavy based on our all of everything we've been dealing with, right? Everything we've been working on with, right? It's still, right, we're still dealing with intervals, right? So of course, if for some reason you need an extra refresher or anything like that, don't forget the tutoring center is available. I'm also available by email or by office hours, right, by appointment. So if you have any questions or concerns regarding any of the previous material, just please let me know. And thank you very much for your time, and I hope you enjoy the rest of your day. Thank you.